Welcome to Probability and Statistics. In this lecture video, we're going to talk about the central limit theorem with proportions. A long time ago, back in chapter 2.1, I mentioned the word proportion under the relative frequency. Proportion is just another word for percentage. Okay, so we're going to talk about the central limit theorem with percentage or proportions. So for example, assuming that in our class, everybody in our class is the population. So let's say Mr. Chen randomly select 15 students and 12 of them favor me dropping the lowest test grade. So the population proportion using the lowercase p of students in favor of dropping low test grade will be 12 students in favor out of 15 students. So 12 out of 15 will be 0.8 or 80%. Okay, so the population proportion P is actually referring to a fraction or percentage of population that has a certain characteristics. So our certain characteristics in this example will be favor of dropping students' lower test. Now, another place we saw the letter P is probability of success, okay, under binomial, which is almost the same thing, because if 12 students favor dropping lower test, so you can either favor dropping lower test or not favor it. So it does have that kind of probability of success and failure sense into this proportions. Okay, so in a minute you'll notice a lot of formula look kind of similar. Okay, it's because it does have that kind of sense of it's not the same thing. It just has the sense of built into it from binomial. All right. So your population proportion, okay, make sure you find this on the formula sheet, is given by P is equal to X over N. X would be your random variable. Excuse me. X will be the number of people that has a certain characteristic divided by the population size. All right. Now, a sample proportion. So let's pretend the students in Mr. Chen's online classes is a sample of all his Math 120 students. Okay, so sample proportion is given by this thing called a p-hat. You know, like a hat you wear. P-hat. P-hat is the X divided by the sample size. Okay, that's what a p-hat. Sample proportion versus population proportion. All right. So what we want to do is talking about the mean and the standard deviation real quick, just like we did with the sampling distribution of X bar. All right, and then we will learn how to find the probability as well. So mean and standard deviation of a sampling distribution of your sample proportion p hat. All right, same thing. See, some of the stuff look very familiar. When the sample taken are simple random samples, the condition for a binomial distribution are met, and the sample size is large enough to ensure that n times p is greater than or equal to 5 and n times q is greater than or equal to 5. Then a normal distribution can be used to approximate the binomial sampling distribution of sample proportions. All right. So the mean of your p hat, okay, the mean of your sampling distribution of p hat, it will eventually equal to the population proportion p. The standard deviation of your p hat will be square root of p times q divided by n. All right. So once I got my mean and the standard deviation, we can do the same thing, which is standardize, okay, our problem into z-score, so we can find the area under the curve. All right. So real quick, just to let you know, the difference between when we're talking about taking sampling distribution of X bar versus P hat is one of them using mean, the other one is using percentage or proportion. All right. So sampling distribution of p hat is just like sampling distribution of x bar. Rather than talk about the mean, here we talk about percentage. Okay. That's the difference. Oh, let me erase this. I did this for the other class. I didn't erase it. All right. So the formula is a little bit different. That's okay. I'm gonna keep this picture right here. Sorry about that. I didn't see I left it out. So again, I'm gonna write down these stuff for you. Okay, so you know what's going on. So this is just things I organized for you to see. All right. Suppose, for example, 40% of the population has a Crohn's disease. You know, so I'm using percentage. So this 40% got to be the mean of the population, which is now is the same thing as the mean of my sampling distribution p hat, which will equal to they will be the same thing eventually, which is 40%. So if we take a random sample of 455 people, what is the chance that the proportion of the sample person with a Crohn's disease will be less than 34%? All right. So what I'm testing here, what my p hat, okay, the percent, so the p hat is your sampling proportion. So the sample of the 455 people that will have Crohn's disease, and it got to be less than 34. What's my chance of that will be less than 34% of the people I sampled? So that would be less than 0.34. Okay, so that's my p hat. All right, so the sigma of a p hat, right down here. If you just look at the formula up here, there's the sigma of the p hat will just be square root of my population proportion p, which is 40%. So that means my q is 60%. So p times q divided by the sample size 455. Okay, the 455 is inside the square root. Okay, so basically what's going on with the graph is, you know, our random variable becomes my population, my sample proportion p hat. Okay, so I can change this axis to p hat. So the mean eventually will become 40%, 0.4. What's the chance that all the 455 sampled it, less than 34% will have Crohn's disease? So I'm looking for the area to the left of my p hat. So again, we can standardize, okay, our axis, convert the 0.34 into a z-score, then we can find the area under the curve. Alright, so let me just copy this formula to convert into z-score. Okay, this big old formula. Oops, sorry. Okay, got the formula right here in mind. So when I extract this information from the problem, I'm actually looking at this formula. So my z-score will be my p hat, which is 34%, my sampling distribution p hat, minus a population proportion 0.4, divided by the standard deviation of the p hat, which is 0.4. Since I already wrote it right here, I'm going to copy it, okay? I'm just gonna copy and paste it. I'm gonna rewrite it again. Put it right there. Alright, we're gonna round to 2 decimal places. So in the calculator, I'm gonna let the calculator subtract the top for me first. 0.34 minus 0.4, close parenthesis, divided by open parenthesis again. Second square root. My square root open the parenthesis first. So inside is typing 0.4 times 0.6 divided by 455. Close the parenthesis for my square root. Then close the parenthesis for my entire denominator. Negative 2.61. Okay, so the z-score here is negative 2.61. Alright, so in other lecture video I mentioned that it's always best to go ahead and convert into a z-score. Okay, otherwise your decimal answer will be off. Okay, because what's different here is the z-score. Okay, the sigma is not the sigma is actually not the same is referring to for the sampling distribution. It's not for the population here. So your standard deviation for the distribution is a little bit tighter. It's a little bit smaller number compared to the regular for the population. Alright, so looking for the area to the left, so that would be normal CDF. Going to negative infinity, so that would be negative 1e99, comma, negative 2.61. Sorry, not m, comma, 0, comma, 1. So let's see what this area is. What's the chance for the one I sample? Whatever. The chance for them to, the probability for them to have Crohn's disease, less than 34% of people will have Crohn's disease. Less than 34% of people will have Crohn's disease. Negative 1e99, comma, 2.61, comma, 0, comma, 1. Very tiny. 0.0045. So less than 1% of people were less than 1% chance that 34% of people or less will have Crohn's disease. So probability is real small. Alright, so if I raise my percentage here, if I want to say what's the probability that the percentage of sampled person with Crohn's disease will be less than 67%. 67%. That will be right here to the left. Okay. Those probability will be a little bit greater. Let's check out another problem here. Same thing. Let's say suppose 45% of doctors in the hospital are surgeons. Okay, so that's my population proportion of doctors that are surgeons. So let's take a sample of 457 doctors. What's the chance that the sampled proportion? So what's the probability of the one I sampled of surgeons will be greater than 39%? What's the chance that 39% of the one I sampled will be surgeon? That's what the question is asking. So let me put it right here. Alright, so the mean of the distribution will eventually equal to the sample mean. Or sample, excuse me, population proportion, excuse me, 0.45. Alright. My p hat, my sampling proportion, 39% will be greater than, so that will be greater than 39%. Alright, the one I sampled, 457. So for the mean of the percentage is 0.45. 39% is a little bit to the left. Alright. What's the probability that 39% of the one I sampled will be surgeon? So I'm looking for the area to the right. Greater than, looking for to the right. Big area. So let's find our z-score. Real quick. Alright, my population proportion P is 0.45. So if a P is 0.45, Q got to be 0.55. So I'm gonna bring this one back here. Alright, so my z-score P hat 0.39 minus population proportion P. Oh man, I even wrote this stuff around wrong. The mean of the P hat. Sorry about that. I didn't mean to write it down in my notation wrong. It will eventually become P. Let me make sure I write it down right. Yeah, the mean of the distribution P hat. Sorry. Calculator P. Minus population proportion 0.45 divided by square root of population proportion P 0.45 times 1 minus P or Q 0.55 divided by my sample size, which is 457 doctors. Two decimal place. 0.39 minus 0.45 in the parenthesis divided by open parenthesis again. Second square root 0.45 times 0.55 divided by 457. Close two parentheses. Negative 2.58. Alright, so this z-score here is negative 2.58. I'm looking for the area to the right. So normal CDF starting from negative 2.58. Oh Lord, 58. Did I say 58? Yeah, I wrote 9 here. Keep on going to the right. Negative 1E99, comma 0, comma 1. All right, 0.9951. Okay, so what the answer is saying is there is 99.51% chance that the sample surgeon, okay, the one that I sampled will be greater than 39%. So that means how many percent of the how many percent of the doctor I sampled, the one that's being a surgeon will be greater than 39%. My chance is 99.51% chance. Okay. Alrighty. So that's how we dealing with the sampling distribution of p hat. Okay. Just like the sampling distribution of x bar. except the formula is a little bit different. So again, we got to find the z-score first before we can do the normal CDF. Okay, and when we read these problems, you need to understand whether I'm looking for the area to the right, to the left, in between, or the two tails. Okay, now in the lecture video with chapter 8, okay, we're going to actually talk about something slightly different, which is still related to what we just did, especially with these formulas. These formula doesn't go away. Okay, so that will conclude this lecture video. Thank you for watching.